Hi everyone. So I just wanted to record an example. So I wrote the example up in class, but I wanted to make a recording of it so you could sort of go over it a bit slower if you wanted. So the example I had in mind was to try and find the limit as x goes to -4, the square root of x squared plus 9, subtract 5 all over x plus 4. And this is going to be one of these limits where you think, okay, maybe I'll start by just plugging in the number. Maybe it's going to make sense like that, and that'll be the limit. So if I just plug in x goes to -4, I see the problem. So on the denominator there, I'm getting -4 plus 4, so that's 0. On the numerator, I'm getting, I guess, 16 plus 9, so that's 25. Square root, that's 5. Subtract 5, that's 0. So whenever we see this, we sort of we think this is a problem. So we need to do some simplifying algebra to see if we can clear up the problem. So in this situation, I see that I've got a square root on the top. And what I really like is to see on the top an x plus 4 that I can cancel against the x plus 4 on the denominator. But in order to get the polynomial outside of the square root, so it's kind of trapped in there, I've got to rationalize. So rationalize so I'm going to rationalize the numerator in this case, but it may be in a different problem you want to rationalize the denominator. And you might remember this process from pre-calc, but let me remind you, it's based on the difference of two squares. And so that means this simple algebraic trick that's a very good thing to know is that if you ever see two squares, one subtracted from the other, it always factors like this. And usually it's used backwards. So if you see like a minus b, so for us this is going to be a, this is going to be b, and what you'd like to do is end up with those things squared. Well, what you can introduce is the a plus b, and that's going to eventually square something. So we'll see how that goes right now. So this is going to be, always got to keep writing limit all the time. So limit as x goes to -4. Now I introduce the a plus b. So that's going to be square root x squared plus 9 plus 5. So that's a plus b. And I'm multiplying that in. And of course, whatever I do to the top, I've got to do to the bottom. So let me just finish writing out this thing. If I multiply on the top, I've got to multiply on the bottom. So now by the difference of two squares, the top is nice and clean. It's going to be the a squared subtract the b squared. The bottom is going to be a mess, but hopefully we'll have achieved something in this mess. Okay, so on the top we're just going to expand that guy out now. So square of a square root, we're just going to get this. 5 squared is 25. And then again, we're just going to get, this is a good trick when you're writing like this, you can copy and paste. Okay. So again, see no change on the bottom. All right, so then we subtract. And we're going to get x squared minus 16. And then we'll see the same thing on the bottom, nothing's changing. Okay, so now actually we're going to use the difference of two squares backwards, because on the top we see the difference of two squares. Alternatively, you can just say, we've got a polynomial, let's factorize that thing. So, always got to keep writing this, very tedious, but got to keep track of what's going on. And so factorizing that polynomial, we get x plus 4, x minus 4. And this is great because that's what we wanted to see on the top, is we wanted to see this x plus 4 to cancel. And remember, when we're taking the limit, we never actually look at the value x equals negative 4, which would be the time that we couldn't cancel that thing out, because the function would not even be defined. But we're in good shape. So we've cancelled those two things out. So now I'm just going to plug in negative 4 to the other parts. So the first thing I'll do is like a little bit of like mental check that I'm not getting another 0 over 0 problem, but it's looking good because that's negative 8. And this thing's going to be, let's see, 16 plus 9, so that's 25, square root plus 5, we're getting 10. So that's very nice. We're going to get negative 4, square root 16 plus 9 plus 5. And that's going to all come out very nicely to be negative 4, well, let's do negative 8 over 10, which is negative 4 over 5. Okay, so I just wanted to